Hey guys, I have your notes for 8-2, day 3 pulled up, and I think you're going to like this. It's going to go kind of quickly. I'm going to show you how to do some cool things on your calculator. So, good news is you don't have to show much work on these. The bad news is when you exclusively use your graphing calculator, there isn't much partial credit I can give you on a test or quiz. So, let's get this down. Let's get it right, okay? So we've got two functions. We've got a trig function and a parabola. We don't have to graph them and draw them, we don't have to graph them by hand. We're going to do all the work on our graphing calculators. There is a tiny bit of stuff that we need to show on our paper, but let me tell you what to do on your graphing calculator first. So I'm going to switch screens here. And I'm going to plug in my graphing calculator. There we go. All right. So I'm in, first of all, make sure you're in radian mode because we're going to be graphing some trig. I would put one of your equations in y1, put the other one in y2. And to graph it with a good normal window, who knows what you've been doing on your graphing calculator up to this point. So to graph it in a good window, you could just automatically push zoom standard. Zoom 6 is zoom standard. And it'll graph it in a really nice 10 by 10. It's actually 20 by 20 window, but whatever. Okay, so you should see there what the curves look like. You can see your area that you need, that's needed here. You could zoom in a little bit. And here's what's cool. When you zoom in, let's say I wanted to zoom in kind of over here, which I don't, but if I did, see my blinking cursor? If I just moved my cursor over there before I hit enter, it would zoom in and this would be the center. But I want it to zoom in at the origin, so I'm going to leave my cursor there, and now I'm going to hit enter on my zoom in feature. There you go, it zooms in. So we can see that the cosine function is actually on the top. The parabola is on the bottom. So I'm going to go, when I set up my integral, I'm going to go trig minus parabola. And we need to find these two intersections. So I'm going to do calculate, intersection, choice 5. Now, I want to do this intersection first. So I'm going to scoot my cursor a little bit closer to this intersection. I'm going to scoot it to the left just a bit. Okay, and it's blinking, and it says, which one do you want to be your first curve? Well, I want my first, it doesn't matter. You choose both curves, but I'm on cosine right now. I can hit enter for my first curve, and then it automatically jumps to what it thinks is my second curve. And so that's my y2, and it says, do you want this to be your second curve? And I'm going to say yes, so I'm going to hit enter. And then it asks me a really stupid question. It says, do you want me to guess what the intersection is? Yes, graphing calculator, guess the intersection for me, please. And you can see the x-coordinate of my intersection and the y-coordinate of my intersection. Now, we're going to use vertical rectangles on this, obviously, because if I draw my rectangles, they go from trig to parabola each time. Vertical rectangles. So the x value is what I really want for my intersection. Now, this is an irrational number, and I'm going to show you how to store this number in your calculator. So while I've been talking, if you've hit any other buttons, I want you to come back to this. So if you've done anything else, I want you to redo your calculate intersection to where this is on your screen, okay? All right, here's how to store this value. I'm going to go quit. So I'm going to go second mode. That gets me to quit, and it's going to take me back to my main screen. Second, quit. Now, some of you might have stuff there because you were doing, multiplying and adding and subtracting. You might have stuff there. That's okay. The very next thing I'm going to do is I'm going to press my store button. Store is down here. It says STO. I'm going to hit my store button. And it's going to pull the answer that I know was my X value on my graphing screen. And I can store it into any variable that I want. And I know it's going to be my lower limit on my integral. So I'm going to store it as A. So now I need to tell my calculator, hey, calculator, I'm getting ready to give you a letter. So I'm going to hit the green alpha button, and then right below it is the A. Green alpha, right below it is A, and hit enter. And it gives me a confirmation. This is the X value that I just stored as alpha A. All right, now we need the other point of intersection. So go back to your graph. Calculate again. Choose 5. Calculate an intersection. All right, it's right where I left it. So let's move it over a bit. And it's just following that first curve, which is fine. Mine's probably slower than yours. There we go. Oh, I'm far enough. So I'm going to hit enter. That's what I want for my first curve. It jumps down to the next one. Is that what you want for your second one? Yes. So I hit enter. Do you want me to guess the intersection? Yes, calculator. I want you to guess the intersection. And it's just what I thought because it was symmetric. So this new X value of my intersection is the positive version. Let's store it in B, okay? So again, don't touch anything. Do second quit. Hit store down here on the bottom left and choose alpha B and hit enter. Now while I have my graphing calculator plugged in, I think I'm going to go ahead and show you how I use these stored values to do an integral. And then I'll go back and show you what to write on your paper. So I feel like I'm really in the way here. I think that's better. All right. So now I'm back on my main screen. I'm going to do an integral. So I'm going to go Math 9. Oh, man, mine's not set up properly. Okay, well, forget that idea. Let me just, we'll write it on our papers, and I'll show you right now how to pull it back up. When you need to recall one of your variables, all you got to do is hit alpha A, and it's gonna give you what you want. It's gonna give you the letter right there in the place wherever you typed it. So, having said that, I'm going to go back to your notes. Okay, here we go. Remember when we were doing these by hand, we had to graph it, find the intersections, and then set up our integral. So we need to show that we have calculated the intersections. So what I'm going to do is I'm going to take my two functions, so y equals 2 cosine x, y equals x squared minus 1. I'm going to set them equal to each other on my paper, and then I'm going to show my answers. You don't have to say, I used my graphing calculator. We know if graphing calculators were allowed, which they are, we know you used your graphing calculator. So, got this. I got my two x values of my intersection, and this is important. Show that you stored this whole value as A, and show that you stored this whole value as B. Therefore, when we go to set up our integral, you can just say, you don't have to write the value, you can just say I'm going from A to B, the stored values that I've acknowledged on my paper, and then you can go top function minus bottom function dx, and then you can give your answer, which I don't think I ever did. So, my answer was about 4.995. I had to round, and when you round, go to 3. Now, one more thing before we move on. I want to tell you something that's kind of cool. Sometimes when you're given your functions, they're named. So sometimes it might say, find the area enclosed by f and g. And it'll say f of x is this, and g of x is this. And sometimes f and g are super ugly functions. If they already are named, here's what you could do to show your work. If it says the name of this function is f, the name of this function is g, go ahead and do everything like I showed you how to do. But when you show your work, you don't have to write out all the ugliness of this function. If it's an ugly one, you can just call it by name. You can just call it by name. This is showing me exactly what you typed into your calculator because I know what f of x is, it told me, and then you told me what a and b are. Okay, so get used to the fact that you can totally write its name instead of writing out the whole messy function, because you will be timed on your AP exam. Well, you will be timed on a classroom exam. So sometimes writing out the function is going to save you time, depending on how ugly the function is. Alrighty, next one. I'm not going to take the time to go back and show you my graphing calculator screen. Go ahead. They're both in y equals form. Go ahead and graph them both on your graphing calculator. And we're going to have some options on this question. So what I did, to start off with, I said, yeah, here's what my function looks like in terms of x, as x with x as my variable. Or, in case I need it the other way, here's the same function, but in terms of y, in case I need my variable to be y. And I did the same thing up here. So this is my function with x as my variable. Or, if I need to reverse it for any reason, same function with y as my variable. These aren't quite the same because this is like half of. It's the positive half of this parabola. So if you're doing these by hand, if you would ever graph this by hand, you can't graph this entire parabola and say it represents this function. What you see on your calculator is the correct function. We can use this one because we're going to set up limits that would kind of limit us on whatever we choose to do. Anyway, I hope that made sense. On your graphing calculator, you probably did a calculate intersection, and you found that when I set this function equal to this function, I get x equals 4. Again, no need to show your work here. Just show what this represents, right? Like, where did this come from? It came from finding the intersection of those two functions. Okay, and then, because I don't want to keep going back and forth between graphing calculator and iPad on my screen, it's too time consuming, I just drew the graph. You don't have to. You've got the graph on your calculator. You don't have to draw the graph when you're using a graphing calculator. I just wanted to draw this for you because you've got options here. Let's see what our options are. Let's try drawing vertical rectangles. Blue to red, blue to red, blue to red. Oh, wow. Oh, hold on, time out. One thing I wanted to point out. It didn't just say find the area between this function and this function. It gave you 3 boundaries, so 3 fences. It said this is a fence, above. This is the fence above. Below, one of your fences is the x-axis, and the other fence is this line, right? So I did not color beyond the x-axis. Fence number 1 that it mentioned, fence number 2 that it mentioned, and fence number 3. That's why I only colored this. Okay, so having said that, so just simply doing blue minus red to get heights is not going to work. Let's see if horizontal rectangles work any better for me. So here I can go red to blue, red to blue, red to blue, red to blue, red. Oh, I like it. Horizontal rectangles would work fine. One integral. We're going to go from a low y, start accumulating to a high y. So I'm going to start at 0 and I'm going to go to high y, high y. What was my y? I don't know what the y is. I think it's 2. Red on the right minus blue on the left. That is an option. And I'm going to write it on my paper here in just a minute. But let me go back to what I was doing. Remember when I did this? Blue to red, blue to red, blue to red works fine. I missed a little bit here. Blue minus red works fine from x equals 2 whatever. X equals 4, I think. Okay, terrible drawing. Drawing, not to scale. That works okay from 2 to 4. I could use an integral to find this. But I need a different integral. Let me switch colors. I need a different integral to find the rest of the area. How would I find this? I would take simply the area under the blue. Just simply the area under the blue. Okay, so over here I've given you several options. And you know what I think I did? I think I totally confused you by switching colors on you. So I think I colored this one red in the problem and this one blue in the problem. That should be better. Because I color-coded my functions and I think I drew the picture wrong. So let me show you what I was talking about first. First thing I said was horizontal rectangles. That would be this one, okay? Listen to me for just a minute before you pause and copy all this down. This is horizontal rectangles. Horizontal, remember I went from here to here, here to here, here to here. I started my accumulation at 0 and I stopped it at 2. Line minus the radical one, dy. Horizontal rectangles. These are y's. These are y's. This is y. Option number 2, I said you could make vertical rectangles here and vertical rectangles here, but you've got to do your integrals separately. So for that option, you can go 0 to 2, just the area under the root function. So I'm going from x equals 0 to x equals 2, area under there. Plus, pick up at 2 and go to 4. Okay, my drawing is terrible. Pick up at 2 and go to 4 and do root function minus line. These are x's, these are x's, this is dx. These are x's, this is an x, this is dx. Make sure it all matches. And then, I guess somebody decided to get a little crazy at one point and they said, well, couldn't you just do, let me switch colors, all the area under the red minus all the area under the blue? Well, sure you can. Some of you think and see things a little weirdly, differently. You can do all of the area under the red and subtract all of the area under the blue. that's an option as well. And whichever way you go with this, you should get a final answer of 3 1/3 for all these options. 3 1/3, 3 1/3, 3 1/3. Feel free to write it as 10/3. It's all good. Either way. Alrighty, enjoy.